Hello everyone. Today we are going to give a presentation of our CIS 6-stage authoring tool, the MagicPuff. Our group members are Bihua Qiu and Sumeng Wei. This video clip is an example showing the main features and capabilities of the tool. You can see that we are able to control the smoke by morphing it from a little chicken to a rabbit. Let's first take a look at the goals. Currently, the smoke simulation has been divided into two parts. The first, physically based method and the non-physically based method. Although current software packages like Maya is able to enable users to implement some fluids with exerts forces like winds and gravity, it is still difficult for artists to process more powerful control of the system. That's why we need a new way to control the smoke however we want. So let's first take a look at the main capabilities of our authoring tool. By loading the source 3D models and the target models, the plugin can create morphing animation between the two models. Besides, by loading an animation clip, the plugin would create an animation of smoke substituting the original characters. Most of our work is based on the paper Target-Driven Smoke Animation, written by Renan and Danny, and we also refer to other papers like Keyframe Control of Smoke Simulations, Stable Fluids, Visual Simulation of Smoke. Our work builds upon the basic smoke simulator in CIS 563. We add driving force to carry our smoke from one state to another, gathering turn to counteract numerical dissipation that causes smoke to diffuse, and the momentum attenuation to limit the accumulation of the momentum in the system. In this way, we are able to drive the smoke from one status to another. As for implementation, we use Qt for testing and Maya C++ API for rendering. MagicPuff in Qt is a standalone application including the function of displaying 3D models, voxelizing 3D models, setting up, processing, displaying, and recording the target-driven smoke animation. And after we finish the Qt part, we migrate the codes into Visual Studio to make a plugin for Maya to get more satisfactory outputs. We use the simple fluid emitter node that Frank offers to import the C++ grid into Maya. And here's some basic user interface which will be explained later. Combine these two, we get our authoring tool. And let's move on to what we have achieved independently. Firstly, we made some modification to the basic smoke simulator. We implemented a hyperbolic solver for advection instead of the method used in CIS 563 because we will use this solver later for implementing gathering turn. And we implemented preconditioner method, speeding up the pressure projection. Secondly, we need to import some materials, transfer them into grid, and set them as the start and end status of our target-driven solver. And we accomplished this for pictures, 3D models, and 3D animation. For importer, we use QImage in Qt and SDBI picture reader in C++ to reading pictures, and we write an OBJ file importer to reading 3D model files. Then for smokization, which means voxelizing the imported materials, we build an octree structure to do this job. Finally, we implemented the target-driven algorithm, including the driving force, gathering turn, and momentum attenuation. During the implementation of our project, we use 563 smoke simulation framework. We also use SDBI plugin domain picture reader to process picture in C++. And we use Qt building up interfaces and OpenGL rendering for testing. And finally, we use the Simple Fluids emitter node to migrate C++ grade into Maya to make a plugin.
Very easy to use. We can see a menu appear in the main menu area called MagicPuff after we activate the plugin. Click on the button and there are two submenus called Smoke Heist and Puff. Smoke Heist is used to voxelize the import materials, such as pictures and 3D models, into a smoke grid, so that we can check if the status in tiny general animations are right. Open up the Smoke Heist window, we import some materials. Then we can change some parameters to customize voxelization. Then we click Create to see the voxelized version of the material. And we open up the Proof window. Same as what we did in the Smoke Heist window, we import some materials. And we can revise some parameters we like. And then we click Create Grid Files, and we'll just wait until it stops. The output files are located under the Grid Files file. And after we create the grid files of our simulation, we open up the rendering setting out window. We can choose whatever we want our output to be, and make sure that we're not rendering single frame. Then we can decide which frame we want to render. We click Render Grid Files. And when we finish, we can find output files. And make them a movie.